Another thing you're looking at this week is limits. So here we're doing Edco Sample A, paper 1, question 6. And you'll kind of see the introduction to limits, and we'll do more on that in calculus. So the first thing here, they give you three functions. One linear function there that we can see. X plus 2, you've got g of x and h of x. Now all they ask you to do is fill in the table. So this will be handy marks. So there's our different values of x. For each of them, fill in 1.9 and for x there, and anywhere you see x, and continue that there pattern. So the first one, when you fill in 1.9 for x, x plus 2, 1.9 plus 2 is 3.9. 1.99 plus 2 is 3.99. 2 plus 2 is 4. 4.01 and 4.1. Continue this on for g of x now. So 1 over 1.9 minus 2 is minus 10. And fill in 1.99 minus 100. So these aren't tending towards anything, as we'll see. 2 minus 2, now when we divide by 0, 2 minus 2 is 0, we should get math there. So it's not defined. 100. This one's probably 10, is it now? 10. And repeat that there for h of x. So x squared minus 4, 1.9. 39 over 10, or 3.9. 3.99. Now this one's also going to work out as 0. 2 minus 2 is 0 down the bottom. Fill it in if you like. .01. Fill the other one's probably 4.1. Now, the next bit. From your answers in part A, decide whether or not a limit exists as the value of x approaches for 2. So if we look at first one, x plus 2, we can see that as the values of x get closer to 2, so 1.99, think of €2, 1.99, 2, these values tend towards 4. And again here, this is repeated going from the other direction, values above 2, 2.1, 2.01, as the values get closer to 2, the answer tends towards 4. Now the way they write that in maths is this thing known as a limit. So they write limit as x goes towards 2. So as values of x go towards 2 of this function x plus 2, it goes towards 4. So as x gets closer to 2, the value of x plus 2 gets closer to 4. Now sometimes you can see it, they might write limit as x goes to 2 minus, and what that means is values below 2, that function goes towards 4 as well. So it's not meaning negative values, it means values below 2. And if they're looking at values above 2, just put a wee plus there as well. So this introduces this idea of a limit. So is there a limit here? Yes. Reason, you could say tends towards 4, or limit is 4, or values go towards 4. Now if we look at the next one, do we see values going towards anything? We don't. Minus 10, minus 100, that's not defined, 110, so it's not going towards any set value. So is there a limit? No. It doesn't go towards a value. Don't converge towards a value. No limit exists. No limit exists as x goes towards 2. And in this last one, it actually does get closer. So you look there, 3.99 or 3.9, 3.99, and same here, 4.1, 4.01. So similar, as we said up here. The reason it's similar is up there is because if you want to factorize that, that becomes, it's your difference of 2 squares, x plus 2, x minus 2 over x minus 2, and your 2x minus 2's cancel, so they're essentially the same thing. We don't get a value for 2 because, as we say, if you divide by 0 you get math error, but that and that are the same thing. So if you factorize that top line, you will get a difference of 2 squares and you'll cancel out your like terms. So generally in limits, always try and factorize when you can. So a limit does exist, yes, and it tends towards 4. Our limit equals 4 is same as the first one. And then the last bit here, decide whether or not f of x, g of x, and h of x are continuous. Now if you look in your notes, continuous just means there's values for all inputs, you know, so for each input x there's going to be an output y, or if you're graphing it, you wouldn't have to take your line off the page. So x plus 2, there you go, you wouldn't have to take your line off the page. Now these boys, they're undefined for 2, so you would have to take your line off a page there, and the same here, even though it works out to be the same, but if we're strictly speaking using that there function, you would have to take your pen off the page graphing it, and it's not defined up here. If there's a value not defined, if we cannot get a y value, we cannot get a range, we cannot get an output, the function is not continuous. So it's continuous for f of x, as we always get outputs, not continuous here, not continuous here. So you could say it's undefined for your ones that aren't, continuous undefined for x equals 2, and same down there, undefined for x equals 2. And it's continuous, what you could say, outputs for each input. When graphed, you wouldn't have to take your pen off the page. Sorry, that went a wee bit blurry just looking at it there. Right, that's it.